On June 11, 2025, beneath a bright winter sky on New Zealand's Mahia Peninsula, Rocket Lab's Electron rocket thundered skyward, carrying with it not just another payload to orbit, but a bold statement of progress in the global space economy. The mission, dubbed the Mountain God Guards, successfully delivered the QPS-SAR 11 satellite, named Yamatsumi, one after a revered Japanese deity, into a precise sun-synchronous orbit. This achievement marks another chapter in Japan's ascent as a key player in the next generation of Earth observation technologies, led by the rising Fukuoka-based private space company, iQPS, Institute for Q-shu Pioneers of Space Incorporated. This mission represents the fifth collaboration between iQPS and Rocket Lab, and is the latest in a series of planned launches to realize a full constellation of 36 synthetic aperture radar (SAR) satellites. When fully deployed, this network will offer near real-time radar imaging of any location on Earth every 10 minutes, an achievement that would place Japan at the vanguard of space-based Earth monitoring. More than just another launch, this event is a nexus of cultural symbolism, commercial ambition, technological sophistication, and geopolitical strategy, woven into the modern tapestry of space exploration. SAR and the rise of persistent Earth observation. At the core of the QPS-SAR initiative is synthetic aperture radar, a technology that allows satellites to see the Earth's surface regardless of weather conditions or lighting. Unlike optical satellites, which rely on visible light and are hindered by clouds or darkness, SAR satellites emit their own radio waves and record how those waves bounce back from the Earth. This allows for 24/7 monitoring, even through thick cloud cover, rain, smoke, or dust. Yamatsumi 1, the 11th satellite in the QPS-SAR series, uses a sophisticated CFRP, carbon fiber reinforced polymer, body, enabling a lighter mass and greater thermal resistance. Upon reaching orbit, it unfurled a large, umbrella-like antenna system measuring over 5 meters across. This deployment is a feat of precision engineering, allowing the compact spacecraft to perform high-resolution imaging at 70 centimeters per pixel, enough to identify vehicles, monitor infrastructure, detect changes in vegetation, or track ship movements. These capabilities are vital in a world where climate change, urban growth, natural disasters, and geopolitical uncertainty demand constant observation. Unlike traditional satellite programs that might revisit a location once every few days, the QPS-SAR Constellation aims to drastically shorten that interval. With rapid revisit times, this network will empower governments, businesses, and relief organizations with the kind of real-time insight once reserved for the military or intelligence sectors. Cultural symbolism and strategic messaging. The naming of this mission after Yamatsumi, a kami deity, in Japanese Shinto belief associated with mountains and natural forces, is more than poetic. It connects the cutting-edge science of orbital mechanics and advanced radar imaging with Japan's deep reverence for nature and balance. Yamatsumi is traditionally seen as a guardian of the land, an entity responsible for watching over Earth's vast and dynamic terrain. In choosing this name, iQPS not only honors cultural heritage, but underscores the satellite's symbolic function as a protector from orbit, vigilantly observing the Earth for signs of change or disruption. Such symbolism is not incidental. As more countries enter the space domain, national identity is becoming an increasingly visible thread in mission planning, naming, and public engagement. For Japan, which balances centuries of tradition with world-leading technological prowess, missions like these reaffirm its position as a modern nation that deeply values continuity, responsibility, and precision in its scientific pursuits. The Electron rocket, enabler of constellation ambitions. This mission also highlighted Rocket Lab's crucial role as a launch partner. The Electron rocket has become the workhorse of the small satellite industry. With a height of 18 meters and a payload capacity of 300 kilograms to low Earth orbit, Electron is uniquely suited for dedicated missions like this one, where timing, altitude, and orbital inclination must be customized for maximum utility. June 11th marked the 66th flight of Electron and its third successful launch within 24 days. An impressive cadence that reinforces Rocket Lab's reputation for reliability and agility. Rocket Lab's flexibility is especially important for constellation operators like iQPS, who need consistent access to orbit to scale their systems effectively. Unlike traditional rideshare launches where small satellites are secondary payloads on larger rockets, dedicated Electron missions give customers control over launch schedules and orbital destinations, critical for maintaining the tight spacing and precise alignment needed for a high-frequency SAR network. The success of the Mountain God Guards brings the total number of satellites launched by Rocket Lab to 227, a figure that reflects the company's rapidly growing influence in the commercial launch market. In addition, the company's upcoming Neutron launch vehicle, a medium-lift, partially reusable rocket, suggests that Rocket Lab is not content to remain in the small lift segment, but aims to compete with SpaceX's Falcon 9 for constellation-scale deployment in the future. iQPS and Japan's strategic leap forward. While Rocket Lab provides the launch muscle, it is iQPS's long-term vision that propels this effort forward. Founded in 2005, the Fukuoka-based startup has steadily developed expertise in small satellite design, with a particular focus on SAR miniaturization. Until recently, SAR systems were confined to massive government satellites the size of buses. But iQPS's innovation lies in reducing this technology to CubeSat-scale platforms without sacrificing image quality. With Yamatsumi, one now in orbit, iQPS has 11 satellites operational, with plans to accelerate deployment over the next 18 to 24 months. The company's endgame is clear: to become the global leader in commercial SAR imaging, rivaling players like Capella Space, ICY, and Synspective. Its proposed constellation will provide a unique service offering, delivering data not just with high spatial resolution, but also with high temporal resolution. This means clients can monitor changes in near real time, giving them critical situational awareness that is responsive, actionable, and scalable. Japan's government has supported this commercial momentum with policy initiatives aimed at encouraging space entrepreneurship, simplifying licensing, and investing in key technologies. With iQPS's success, the country may soon move from being an emerging commercial player to a dominant force in the Earth observation economy, particularly in Asia-Pacific, where environmental monitoring, maritime security, and disaster response are top priorities. From data collection to decision-making, the most profound impact of the QPS-SAR constellation may lie not in the satellites themselves, but in the data they produce. With 10-minute revisit times, users will be able to observe how a city gridlocked with traffic clears throughout the day, how floodwaters rise and recede hour by hour, or how shipping patterns shift in the South China Sea. This kind of temporal detail transforms raw imagery into a decision-making tool. For agriculture, this means farmers can track soil moisture or crop health in near real time, adjusting irrigation or fertilizer levels with scientific precision. For humanitarian relief, aid agencies can see how flood zones or earthquake-affected areas evolve, planning their deployment routes more efficiently. In urban management, local governments can identify illegal dumping, track construction progress, or monitor deforestation. In national security, rapid revisit imaging allows defense agencies to detect new infrastructure or suspicious activities within hours, not days. The future will likely see SAR data integrated into machine learning pipelines, predictive modeling tools, and geospatial analytics platforms, turning petabytes of orbital data into visualized, digestible intelligence. iQPS has hinted at offering its own platform as a service, where clients can subscribe to specific data streams, customize alerts, or integrate imagery with other GIS. geographic information system databases, toward a constantly watched world. As the sun rises and sets on Earth, Yamatsumi, one silently sweeps across its orbital path, one of many eyes that will soon compose a vast celestial network. Together, these satellites will offer an unprecedented view of our world. Not just what it looks like, but how it changes minute by minute. In a time when humanity faces simultaneous environmental, economic, and geopolitical upheaval, this ability to see with clarity and constancy may become one of the defining tools of the 21st century. Through the precise engineering of iQPS, the dependable launch services of Rocket Lab, and the cultural spirit embodied in Yamatsumi 1, this mission exemplifies the convergence of tradition, innovation, and global responsibility. It is not only a milestone for Japan's commercial space aspirations, but also a beacon of how orbital observation, when designed with vision and executed with care, can illuminate a more informed, responsive, and resilient world. And so, the mountain god watches, not from ancient shrines or mythic peaks, but from low Earth orbit, scanning the vast lands and oceans below with synthetic clarity, guarding humanity with data, foresight, and the enduring promise of space.